This factory doesn't build houses, it builds cities. Every road, bridge, tower, and wall depends on a material that begins as raw stone. What you're seeing is the full industrial journey of cement, from rock buried deep in the earth to the powder that holds modern civilization together. The process starts far from the factory floor. Deep inside limestone quarries, controlled blasting fractures massive rock formations. These rocks aren't random. They're selected for precise chemical composition, high calcium content with minimal impurities. Once loosened, heavy loaders move in, lifting tons of stone at a time. What looks like destruction is actually the first step of precision manufacturing. The extracted limestone is delivered to primary crushers. Here, rocks larger than vehicles are reduced to manageable sizes. Steel jaws slam shut again and again, breaking stone through brute mechanical force. Dust, vibration, and noise dominate this stage. There's no refinement yet, only controlled violence designed to prepare material for what comes next. Crushed limestone is then blended with other raw materials such as clay and shale. These components are stacked in layers and reclaimed in exact ratios. Every conveyor, every movement is calculated. The chemistry set here determines cement strength months later. Mistakes at this stage can't be fixed downstream. The blended material enters the raw mill. Inside, massive rollers and grinding tables crush everything into a fine powder known as raw meal. Airflow systems separate usable powder from oversized particles. Only material that meets strict fineness standards is allowed to continue. At this point, solid rock has effectively become airborne dust. That raw meal is lifted into towering preheater cyclones. Hot exhaust gases rise upward while material falls downward, creating a counterflow heat exchange. Moisture is driven off, and the chemistry begins to change. Temperatures climb with every stage. This isn't just heat management, it's efficiency engineering that saves massive amounts of fuel. As temperatures increase further, calcium carbonate starts to decompose. Carbon dioxide is released, leaving calcium oxide behind. This transformation can't be reversed. Once it happens, the material is no longer limestone. It's chemically prepared for the most critical stage of the process. Everything now feeds into the heart of the plant, the rotary kiln. Inside this slowly rotating steel cylinder, temperatures exceed 1400 degrees Celsius. The material partially melts and fuses into small, hard nodules known as clinker. These glowing pellets carry the mineral structure that gives cement its strength. This is where raw material becomes a binding agent. Red-hot clinker exits the kiln and drops into the cooling system. Powerful air blasts strip away heat in seconds. This rapid cooling locks the mineral structure in place. The heat pulled out here isn't wasted. It's reused elsewhere in the plant. Efficiency is built into every step. Once cooled, clinker is stored in massive silos. This buffer allows the plant to run continuously. From the same clinker, different cement types can be produced simply by adjusting the final formulation. Storage keeps the system flexible and uninterrupted. Clinker then goes through its final transformation. It's ground again, this time with gypsum. Inside rotating mills, steel balls crush everything into an ultra-fine powder. Gypsum controls setting time, stopping cement from hardening too quickly. Particle size at this stage determines how the cement behaves on a construction site and how strong it becomes over time. The finished cement is pneumatically transferred into storage silos. At this point, the product is complete. Dry, uniform, and ready to be used anywhere on the planet. Finally, cement is packed into bags or loaded in bulk. Automated systems control weight and consistency with precision.
Copy. Things look tight.
Back from the rear.
Slide it in. There we go.
Line. Looks square. Next one's on its way.
From here, trucks carry it to construction sites, infrastructure projects, and expanding cities. What began as raw rock now supports roads, buildings, and entire skylines. This isn't just manufacturing. This is how the modern world is held together.